this review from I don't know how long ago. My math teacher has yet to give us our final review, so I've kind of been working off everything I've gotten this entire semester.
Okay. Okay. And let's see, we're doing an hour this evening, right?
Yes.
All right, hold on. Let me bring my tablet thing up. So they want us to describe the domain, range, graph it, and then compare it to the elementary function.
Okay.
So it looks like they want us to fill out this table also. Okay?
Mm-hmm.
So this table of x and y values. How am I going to make this table?
I do not remember this.
Well, whenever you're trying to graph a function, you can always make a collection of dots by just picking values for x and then what is y. In other words, y is the same as g of x. Okay? So let's pick a value of x that's easy. What if I picked x equals 0? What is y going to be?
0.
Plug it in. In other words, plug in x equals 0 into this, and what do you get for g of x?
7.
So when x is 0, y is 7. That's the same as saying g of 0 equals 7. Okay? Well, what does g of 1 equal? G of x is this function right here. So when x is 1, what is y?
14? I'm not entirely sure.
The square root of 1.
Yeah.
What is the square root of 1?
1.
Plus 7?
8.
That's what it is. Okay? So g of 1 is 8. Let's try g of 4. What's the square root of 4 plus 7?
That is 16.
What's the square root of
7.
What's the square root of 4? Not 4 squared, but the square root of 4.
Oh, 2.
Okay. So 2 plus 7 is 9. So g of 4 is 9. And finally, let's pick an x of 9. Now, why did I pick those 4 numbers for x? Because each one of them has a whole number as the square root of it. In other words, I didn't pick 3 because then our answer would have been square root of 3 plus 7. I picked 4 because the square root of it was 2. It wasn't a decimal. And I picked 9 because the square root of 9 is a whole number also. So what's g of 9?
3.
Well, square root of 9 is 3, but we still have to add 7 to it. That's
10.
Okay, so that's what my table looks like. That's how I get it. And now is all I have to do is graph that collection of points. In other words, you can always graph a function this way. Let me expand it a little bit here. So when x, this is the x-axis, this is the y, or the g of x axis. So when x is 0, y is 7. We'll make that 7. So this point's on the curve. When x is 1, y is 8. When x is 4, y is 9. When x is 9, y is 10. So there's a collection of points, okay? And if I connect those, that's my graph. Well, that looks an awful lot like y equal x, the square root of x. In other words, if I were to graph the elementary function, that being f of x equals square root of x, well, that function starts at the origin and it goes up and starts to flatten out like that. Well, this function looks very similar to that. The only thing is it doesn't start at the origin. So what is this function relative to the elementary function? If the elementary function looks like this,
Yeah.
and this function looks like this, what has happened? What have I done to this function?
The function has shifted up.
By how much?
By 7.
That's exactly what is done. In other words, the consequences of this plus 7 merely takes the original function and shifts it up by 7. Okay? So this function here is g of x equals square root of x plus 7. This one down here is f of x equals just square root of x. Okay? So let's talk about the domain of this function, the g of x function. Domain, what does domain mean?
I don't really remember.
It's all of the allowable values that x can take on.
Okay.
Okay? Can x be minus 2?
Yes.
No, because then we'd be taking the square root of a negative number, which you cannot do.
Okay.
So x has to be at least 0 or bigger. So the domain is x has to be greater than or equal to 0. For us to be able to take the square root of it, it has to be greater than or equal to 0. We can see that if we look at the graph. In other words, remember the domain is all values for x. Well, you don't see any points to the left of the y-axis. So it clearly shows that x has to be greater than or equal to 0. Yeah. What is the range? And the range is what y can be. Look at the graph and tell me what y has to be.
All real numbers?
Well, is y ever 2? You see any points? Not this graph here. I'm going to erase this graph so I don't confuse things. Let's look at this graph here. We're looking at the y values. What's the lowest value you see on that graph for y?
7.
Okay. So there's no way y can be 6. We would see a point on this graph if y could be 6. So the range is y. Can y be a million?
No.
Yeah, it can. If I make x big enough, then y actually will go to infinity. This curve looks like it flattens out, but it doesn't. It keeps going in this direction as x goes to the right. So the range is y has to be greater than or equal to 7, and that means it can go to infinity. Is all you have to do is let x go to infinity, and y is going to go to infinity, or g of x will go to infinity. But again, read the range from the curve. And finally, this transformation it's the elementary function shifted up by 7 units. And that's exactly what you want to say down here. It's the f of x.
Okay.
It's f of x shifted up by 7 units. All right, let's look at the next one. This one here. They want the same three things. First of all, let's fill out a table for this one.
Okay.
We have most of the table. In other words, I'm going to leave those numbers. Now let me take out these numbers. Can x be 0?
Yes.
What would happen if x was 0?
It would be a negative, so it can't be 0?
Can't be 0.
Okay.
The way to figure out what x can be is to always take what's ever under the radical. In this case, it's x minus 6. That's what's inside the radical. That has to be greater than or equal to 0.
Mm-hmm.
Which means x has to be greater than or equal to 6.
Okay.
So my first number that I'm going to put in there is going to be 6. There's no point putting lower numbers than 6. I know that x has to be at least 6. So the range is x has to be greater than or equal to 6. Now I'm going to erase this curve from the last problem, and I'm going to draw the basic function. That's the elementary function. That's f of x equals square root of x. And then we're going to draw the new function. Well, when x is 6, what is h of x, or y?
6.
Plug it in.
0. Wouldn't that get a negative, though?
No. Make x 6. What's 6 minus 6?
Okay. 0.
So you can take the square root of 0.
Okay.
It's 0.
Which, yeah.
Okay. So that's the y value, 0, when x is 6. What's another good value to put on x? What will make this thing a whole number? I suppose 7.
Yeah.
X is 7. What is y?
1.
Okay. What should I make x next?
8.
Well, 8 would be okay, but then y is going to be the square root of 2, which is not a whole number.
Yeah.
So let's make x a bigger number than 8, such that the result is going to be an even number. What would, if I put in x at 10, what is y? I put in any number I want, as long as it's above 6. You know,
Yeah.
all I'm doing is trying to come up with some data points. So what is y when x is 10?
4.
That's the square root of 4. What's the square root of 4?
2.
Okay. So y is 2.
Okay.
Okay? And let's have an x of 15. You see why I picked that?
Yeah.
So what is y when x is 15?
3.
Yep.
3.
Yep.
Yeah. 3.
Okay. So now let's graph that collection of points. And this time I'm going to make the points in blue. Okay? Well, we said when x was 6, well, let's label this thing. Let's make this, here, let me erase these hash marks so I can put some new ones down. Let's see, we want 6, we want 10, and we want 15. When x is 6, y is 0. There's 1 point. When x is 7, there's 7. Y is 1. So there's another point.
Yeah.
When x is 10, y is 2. There's another point. And when x is 15, y is 3. So again, we have a curve that has the same shape as the elementary function does.
Yeah.
Only what happened? What have we done to it?
It shifted down 6.
I can see why you would think that, but
No, it shifted over 6.
over 6. When you have a number inside the function, in this case inside the square root sign, that is a horizontal shift. In other words, there's a difference between the first problem, which was this. That clearly comes after the radical sign. That makes it a vertical shift.
Okay.
In this problem, if I were to stick that 7 inside, that's a horizontal shift to the left. So if I, instead of put that plus 7, I make it our function so that I make it minus 6, that is a horizontal shift to the right of 6 units.
Okay.
And that's how I make this curve, is I start with my red curve and move it 6 units to the right, and it's right on top of this blue curve. So now let's focus on this to figure out domain and range. What does x have to be?
X has to be greater than or equal to 6.
Correct. So that's the domain. What's the range?
Y is...
Read it off the graph.
Y is greater than or equal to...
You want to say it, I know you do.
Y...
Greater than or equal to what?
0.
That's it.
Yeah.
That's what it is. In other words, this value right here is 0. All these other values are greater than 0. And if you think about it, when you take the square root of anything, the answer is almost always positive. It is positive. It's either 0 or positive. So it makes sense that the range would be greater than or equal to 0. And once again, what is the transformation from this function here?
A horizontal shift to the right.
Yeah, because the standard is x minus h. And if h is a positive number, then it's a shift to the right. And in this case, we have x minus 6, so 6 is a positive number. If I would have had x plus 6, that's a shift the other way. That's a shift to the left, because h is a negative.
Okay.
Okay? In other words, if h is negative, you go left. If h is positive, you go right. But the standard x minus h, where h is a positive number, x minus h. So we have a 6 here. That's a shift to the right.
Oh, I get it.
All right, let's go to 3. Three has a few things going on with it.
Yeah.
Again, all it wants us to tell it is describe the transformations. That's it. We don't have to graph it. We don't have to give its domain or range. We just have to describe the transformations.
Okay.
There's 3 of them. First of all, what's the consequence of the negative sign in front of the radical sign?
It means it shifts to the left?
No. When you see negative signs, that means reflections.
Okay.
If f of x is equal to the square root of x, which it is here, f of x is square root of x, and they want to know, well, what would this be? That would be a reflection over the x-axis, because that's equal to minus f of x. Minus f of x would be minus square root of x. And whenever you have minus f of x, it means you're reflecting it over the x-axis. So if I wanted to graph that, this is the way it would look. Like that. Instead of what we've been looking at, which is like that. A reflection over the x-axis does this. Okay? So that's the first thing that's going on. What's the consequences of the 3 inside the radical sign?
Is a horizontal. Wait.
Yep. But which way?
To the left.
Correct.
Since it's
okay, so here's what we got going on. If we're going to describe these transformations, you always do your reflections first, okay? And you can't just say it's a reflection. You have to say which axis it's a reflection over, because you can also reflect over the y-axis.
Yeah.
So this one is a reflection over x. It's a horizontal shift left 3 units. And finally, what's the consequences of this -1 that comes after the radical sign?
Does it shift down 1?
Vertical shift down 1, exactly. And you want to say all of those things. In other words, again, it's not just good enough to say a vertical shift of 1. You have to say whether it's up or down. So here's the 3 things happening in that function. And these are the order I'm going to do them in. It doesn't so much matter horizontal and vertical shifts, but reflections, you need to do those first. Otherwise, you'll end up with the wrong curve. So let's just graph this for the heck of it. It's 3 units. In other words, the original function looks like that.
Yeah.
Well, first I'm going to reflect it. So that's the first step. Next, I'm going to move this dotted line 3 units to the left. So that would be account for those 2 things. And finally, I'm going to move it down 1.
Okay.
So that's the final curve right there. That's after you've done all 3 transformations. All right, let's look at this one. Okay, this also has 3 things happening.
Yeah.
We'll start with, there's no negative signs. There's the -6, but that doesn't count as a reflection. That's part of a horizontal shift. But what does this 1/4 mean?
Doesn't that mean across the y-axis?
That's a vertical, not a shift, but a stretch.
Okay.
A stretch, or I don't know what your teacher calls it. It's a stretch or scrunch, because you can either vertically stretch it out or you can scrunch it.
Okay.
Okay, so let's call it that, a scrunch. You know what I mean by a scrunch?
Yeah.
Okay, and if this coefficient is greater than 1, it's a stretch. If it's between 0 and 1, it's a scrunch. A scrunch is where the thing gets flatter.
Yeah.
Okay, in other words, let's take our square root of x function. That's what it would look like if it was just square root of x. If I make it 1/4 square root of x, it has the effect of flattening it out like that. If I had 2 square roots of x, it would vertically stretch it up like that. So it depends on whether this number is greater than or less than 1 as to whether it's a stretch or a scrunch. In this case, it's a scrunch.
Okay.
Okay? What's the consequences of this? The -6 inside the radical sign.
Horizontal?
What? Horizontal what?
6. Horizontal shift up 6.
Well, if it's horizontal, it's not up or down. Horizontal means right or left.
Okay.
So it's horizontal, you're correct. But which way?
To the right.
Correct. So instead of looking at this, that's y equal square root of x. Well, I'm going to start it 6 units to the right instead. And I'm going to make it flatter, but then what about this plus 2? What does that do?
A vertical shift to the left over.
Okay. Think about what you're saying. Vertical has to be up or down. That's what vertical means.
Okay, horizontal
means left or right.
Yeah.
So this 6 was a horizontal shift. This plus 2 is what?
A vertical?
Vertical shift by what? Which direction?
2 to the left.
Okay, it's vertical. So it's got to either be up or down.
Down.
No, the plus sign means up. A negative sign would be down, yeah. So I got to start the thing 2 units higher. So now I'm going to start right here. In other words, I've moved my starting point 6 units to the right, 2 units up. Now I'm going to flatten this curve so that it looks something like that. So that's what it looks like. So what 3 things are happening here?
A vertical scrunch.
By 1/4.
Horizontal.
Hold on a second. When you're describing these, describe them fully. It's not good enough to just say a vertical scrunch. You have to say by how much.
Okay.
So it's a vertical scrunch by 1/4. And what's the rest of it?
Horizontal shift to the right plus 6.
By 6 units. Plus what? What's the third thing?
A vertical shift down up 2 units.
Up 2 units. Remember, if this sign is negative, you're going to go to the right. But if this sign is positive, you're going to go up. If this is negative, you're going to go down. Okay? All right. Let's bring up another page here. All right, this one we're going to be talking about cube roots. Well, let's draw what the original cube root function looks like.
Okay.
Cube root function looks like this. That's a cube function. That's not a cube root function. That's y equal x cubed. The cube root function looks almost like that. It's the inverse of this. So the cube root function looks something like that, instead of the first thing I drew. Okay?
Okay.
So this is the cube root function. Let's examine that for a moment. What's the domain of this function? Can you tell by looking at the graph?
Not really.
Well, the domain is what x can be. Now, if I don't have anything on the ends of this curve, it means it goes to infinity in both directions. So are there any restrictions? Can I take the cube root of a negative number?
No.
Yes, you can. Why? Let's take it. Let me take the cube root of negative 8. Well, that's equal to minus 2. Why? Because minus 2 times minus 2 times minus 2 equals minus 8. So if I take the cube root of a negative number, I get a negative number, and that's fine. If I take the cube root of positive 8, I get positive 2. So it's different than square root, okay? All right, so that's the first thing we discover, is that we can take the cube root of negative numbers, we can take the cube root of 0, we can take the cube root of positive numbers. Well, if I look at that graph, it does not look like x is restricted. It looks like x can go to negative infinity in that direction, and it can go to positive infinity in that direction. So the domain would be all real numbers.
Okay.
And we can write that like that. There's no restriction at all on x, all reals. Well, can you figure out what the range is by looking at the graph?
Yeah.
This is the y, okay. What's y going to be? What are the allowable values that y can attain?
All real numbers?
Yep. No, you're right. All reals. In other words, it not only goes to negative infinity in this direction, but it also goes to negative infinity in that direction. And it also goes to positive infinity when x goes towards infinity. Y also goes to infinity. It is all you have to do is kind of experiment. If I take the cube root of 1, I get 1. If I take the cube root of 1,000, I get 10. If I take the cube root of 1,000,000, I get 1,000. Actually, I don't. I get 100. But the point is that it's 100. As you let x go to infinity, y does go to infinity. If I let x get big enough, then y eventually will reach infinity also. Okay? So there's no restrictions on this curve. The domain is all reals, the range is all reals. So now let's talk about translations of this curve. If we look at this thing on the left only, they want us to do the same thing here as we did before. Let's do it. Let's make a table. Hold on. We've got g of x equals the cube root of x minus 4. What's that minus 4 do?
Turns into a positive.
No, you're confusing a horizontal shift with a vertical shift. Because the minus 4 is outside of the function, it's not inside that radical sign, this is a vertical shift. Which way?
Down 4.
Yes. Okay. So what we are going to be looking, and that's the only thing going on here, is a vertical shift down 4. So I'm going to take this exact curve and just move it down to here and draw it, and it'll look something like that. Okay? So what would the domain and range be of my shift? I'm going to draw the shifted curve in blue. It's going to go through this point right there. It's going to look very similar to my other curve, only it was just shifted. It wasn't, I didn't change its shape, I just shifted it. What did that do to the domain and range? What's the domain of the blue line?
Still all real numbers.
What's the range of the blue line?
All real numbers?
Correct. Now, let's make their table. I'm going to make a little table right here. Give me some values for x, and what would y be equal to? Let's start with 0. What is y equal to when x is equal to 0?
4, negative 4?
Negative 4. We can read it right off the thing there, but we can also plug it in and figure it up algebraically. Now, when x is 1, what is y?
Negative 3.
You say negative 3?
Yeah.
That's correct. When x is 8, what is y?
4.
Well, what's the cube root of 8?
2.
What's 2 minus 4?
Negative 2.
Negative 2. Let's plug in some negative values for x. Let's try a negative 8. What's y?
Positive 2.
Well, what's the cube root of negative 8?
Negative 2.
So we got negative 2, and we're subtracting 4 from that.
Oh, that would be negative 6.
Okay. And how about an x of negative 16? No, not negative 16. I didn't mean that. I meant, well, let's see. What's a good value for x? How about negative 27? What's the cube root of 27?
3.
What's the cube root of negative 27?
Negative 3.
What's negative 3 negative minus 4?
Negative 7.
Okay, so that's minus 7. So there's our table. And you'll notice that that kind of matches my values. When x is 0, y is at minus 4. When x goes to 1, y is at minus 3. When x is way negative, y is minus 7. And when x is positive 8, y is still negative. It's right there. So this function is very flat. It doesn't rise as much as I am drawing it as rising. It's flatter than that.
Okay.
All right, let's see. Have we answered everything for this question? We have. Now let's look at 6. I think you know how to do the table. Let's just talk about domain and range. What's the domain and range going to be on cube root functions?
Both are going to be all real numbers.
Correct. In other words, there's no restrictions when you're taking cube roots. I don't restrict x, and y isn't restricted either. What is the difference between this function and this function? What transformation is going to happen?
Vertical up to.
Oh. Remember that it's only vertical if it's after the function. If it's inside the function, it's horizontal.
Oh, horizontal.
Which way?
So, horizontal to the right 2.
To the left 2.
Okay.
It's always opposite this sign. In other words, if this sign is plus, you're going to go left. If it's minus, you're going to go right. If you're adding something after that, it's up. If you're subtracting something, it's vertically down. Let's talk about this just for a moment, because this part is important. Let me this is f of x equals the cube root of x. Okay, that's our elementary function. Well, let's talk about various things we can do. We can make a minus f of x. What would that be?
Wouldn't that be a reflection?
Well, it would be, but what is it exactly here?
A reflection of the x-axis?
This is the answer I'm looking for here. In other words, when I say f of x equals this, minus f of x isn't going to equal minus that. Okay? You with me? That's a reflection over the x-axis. Well, you can also do this. You can have an f of minus x. I don't know if they've talked to you about this yet, but that's where the negative sign goes in front of the x, like that. Okay? That is a reflection over the y-axis.
Okay.
Let's go over the other 4 things that you can do to this function, because there's only 6. There's 2 reflections. And then if I put a multiplier in front of f of x, such as c times the cube root of x, what's that going to be? Let's use numbers here instead of letters. If I put a 2 in front of, what's 2f of x going to be?
Times.
Right, 2 there in front of the function. What's the effect of that 2?
You're going to multiply it by...
What's its effect? Is it a vertical stretch, scrunch, shift?
It's a vertical stretch.
Good. Okay, let's talk about something else. Let's say we put a number in front of the x, like this. Well, that would manifest itself by, I'm going to take the cube root of 3x now, instead of the cube root of x.
Okay.
What's the consequence of this? We haven't done one of these yet. So I'll just tell you, that is a horizontal scrunch.
Okay.
And the difference is that when you're talking horizontal stretches or scrunches, if this number is greater than 1, it's a scrunch. If it's between 0 and 1, it's a stretch. So it's the opposite of the way vertical stretches work. For a vertical stretch, this was a vertical stretch by a factor of 2, but this is a horizontal scrunch by a factor of 3. It's compressing it horizontally.
Okay.
But just remember it's the opposite. Okay, and there's a couple of more things you can do with this function. You can take f of x minus 4, which would be the cube root of x minus 4. So when you have it expressed this way, what's the consequences of the minus 4?
Wouldn't that be, sorry, horizontal shift down 4?
Okay, horizontal is not up or down. Horizontal is left or right.
I'm mixing those up.
It's all right. So what is it? You're correct. It's horizontal, but which way?
Yeah. Up 4? I mean, to the right 4.
The right 4 is correct. Okay? And finally, there's one last thing that you can do to f. You can add a number after everything. And I would write that like the cube root of x, and all I'm doing is adding 5 after the function. What's the effect of that plus 5?
A shift up 5?
Yes. Vertical. Make sure you don't really even need the word vertical as long as you say up 5. The shift up 5. But it's good to use the words vertical and horizontal in all of these. So notice we have 6 different things here. We have a negative sign in front of the function. What is that again? Reflection about which axis?
The x-axis.
What is this one?
A reflection of the y-axis.
What is this one? And what I'd like you to look at is just the left side of this thing. Because this is how you tell.
Okay.
In other words, if you can understand what's going on the left over here, then no matter what you see on the right, you'll be able to express it like it is on the left, and this tells you, as long as you got these memorized, what you're doing. What's the effect of this 2? Or this 2 over here?
You're multiplying it, so it would be a shift. No, a stretch.
Let me give you a way of memorizing that. Because you're multiplying it, let's take y equal x squared, that function. Okay, that's another basic function. Well, if I said, what is the effect of the 2 in front of the x squared? You're right, you're multiplying everything by 2. If I had a point that was there, it's now twice as far away from the x-axis. If I had a point that was here, it's twice as far away from the x-axis. The net result of that is it tends to make this curve more narrow, and that is a vertical stretch. So when you're multiplying the entire function by a number greater than 1, you're vertically stretching it. You're going to say that whatever y would have been, it's twice as much now. And then if you connect those dots, you'll see that this is a vertical stretch. Okay? Now, let's go back to our list, because I think this is the most important thing we can cover today, is these 6 things. Okay?
Okay.
Starting right there at the top. You need to know what this does, what this does, what this does. What does this do you suppose? When you put a number, a multiplier, next to the x so that it goes inside the square root sign or the cube root sign. Take a guess. If this is a vertical stretch, what would this be?
A horizontal
stretch. Perfect. This one down there, what is that?
Which one? I can't see which one you're pointing to.
This one right here.
Okay. Horizontal.
Which way?
Vertical.
No, you got the right word. Horizontal is correct.
Horizontal to the right.
Okay.
Or.
Okay. And then finally, what's this do? Say all the words.
Okay. Vertical. I want to say to the, like, shift. Going down.
Shift. There's 3 things you can do on vertical. You can stretch it, you can scrunch it, or you can shift it. If you shift it, you're not changing the shape of the curve at all. You're just moving it up or down.
Oh, so that would be a shift up 5?
Yes, a vertical shift up 5. That's all of the words. A vertical shift up 5. So let's, if you can, memorize this is what these things mean. Now, the trick is to take this on the right and to figure out what is it in terms of f of x. In other words, if I look at this function right here, and I'm not looking at anything else, I can tell that that is 2 times the function, which is what that says. And if I know that when I have a multiplier times my function, that's a vertical stretch factor. So the secret is to be able to take the function and figure out which of these f of x manipulations it is. All right, let's So, on number 6, just tell me what we're doing to that. There's only one transformation on that happening. Which does that match on my page here? In terms of the left side, what does that look like?
It matches,
let me label these and you tell me the number. Is it number 1, number 2, number 3, number 4, number 5, or number 6? I don't mean exactly. I mean the type of transformation. Yeah. Each of these is a different type of transformation.
Wouldn't it be 1 just without the negative?
No.
No.
How about number 5?
That was my second choice.
Right. In other words, that's what it is. It's f of x plus 2. If I wanted to know what f of x plus 2 is, well, then I start with my function, and instead of writing x in there, I write x plus 2. So if I'm looking at this as the first step, I know to match it with number 5. And number 5 is a horizontal shift to the left by 2 units. Okay?
Mm-hmm.
All right. Let's look at 7. We don't have 7 on this page. Let's see. Solving radical equations. Okay, good. Something new for our last 5 minutes here. First of all, let me give you a little quick lesson here. You want to memorize this on the left. If you memorize anything from today, memorize this page you're looking at right here.
Okay.
And know which it means. Now let's just talk algebra. If I say the square root of x equals 2, how would you solve that equation? We want a final answer of x equals something. Well, how do I make the left side look like x?
I have no idea.
Let's square both sides.
Okay.
If you square something that has the square root of, it becomes x. Well, if I square the left, I got to square the right. So I got my x on the left, and on the right is 4.
Okay.
Does that make sense?
Yeah.
Is the square root of 4 equal to 2?
Yeah.
Then we did it right. Okay, now let's change it a little bit. Now let's say the square root plus 3 is equal to 8. Now solve the equation.
You have to subtract 3 from both sides.
So what's the next line? Just read the next line to me.
So square root of x equals 5.
Now solve that. What do I do to solve that?
Take the square root of...
No. There's a difference between taking the square root of something and squaring something. They're the opposite. One is the inverse of the other. So what are we going to do to both sides?
Square it.
And what's our next line?
X equals 25.
Perfect. Now, let's do another one. What's the first step?
Okay.
Is it to add 1 to both sides, or is it to square both sides?
Square both sides first.
Right, because you can't really add one. This -1 is inside the radical sign. So I can't do anything with it until I get rid of the radical sign. So let's square both sides. What's the next line?
X minus 1 equals 100.
And the last line?
Add 1 to both sides. So x equals 101.
That's how you solve radical equations. One last one. It's the first step.
You wouldn't have to square both sides, would you?
Not yet. What you always want to do is you want to isolate that usually before you square both sides. It actually would work. I could square both sides, but I would rather get rid of this 2 first.
Okay, so subtract 2 from both sides.
Remember, when you're solving algebra problems, you always do the inverse of what it is currently doing. That 2 is currently multiplying something. So if I want to get rid of it, I got to divide by 2.
Oh.
What's the next line?
X.
Square root of x equals 5. Now we can square both sides.
Okay, so x equals 25.
Yeah, so x equals 25 again. So the goal in these solving radical equations is to always isolate the radical, even if it's a complicated radical, even if it's something that looks like this. X plus 1 over 3 equals 6. What's the first step?
Divide 3?
No, that 3 is inside the radical.
Okay.
So I can't multiply by 3.
So you square?
Right. Square both sides. What's the next line?
X plus 1 over 9.
Over 3. In other words, is all I'm doing when I square it is I'm getting rid of the radical sign. That's all I'm doing.
Okay.
Equals 36. What's the next?
36.
The next step?
You need to...
We want to isolate x, right?
Yeah.
Okay, we got to do 2 things to the left side to isolate x. What's the first one? Get rid of the denominators.
Yeah.
Always get rid of denominators, not add 3. What is that 3 currently doing?
Dividing.
So we got to do what?
Divide 3
we got to
from
multiply.
36.
We got to do the opposite.
Oh, okay.
Always the opposite. Okay, so I'm going to multiply both sides by 3. That 3 cancels. We're left with x plus 1 equals 108. And now what?
Subtract 1?
Right, because 1 is being added. So we're going to do the opposite. We're going to subtract 1. X equals 107. That's what you do with radicals, is you isolate not x, but you isolate the radical, and then square both sides.
Okay, I see.
Okay, cool. Kendall, unless you have any last questions, we can stop there, and I will talk to you next time.
All right, thank you.
Bye-bye.